So now we need to visualize the outlier and see what outlier means. Before we separate outlier from our data, the best practice is to split your data. You split the target from the feature. So I will say my feature is capital X. As I have said, every column here except the strength is the feature. The strength is the target. So the best way to split this is to just say maybe df.drop. I'm going to drop all of the columns that doesn't correspond to this, and that's strength. So this will be my X, and my Y. Y is the target. I will use indexing. And then I will simply select the strength. Now, if you simply just do x dot add, you will see that it corresponds to every column except the strength. And if you do y dot head, you will have just the strength. So now we have not visualized. What we've just done to split our data, but we need to visualize and see what the outliers are. So to do that, we will need to have a box plot, and then histogram are the most popular method of visualizing that, but I prefer box plot. I will use a subplot because I will plot for the feature and plot for the target. I will say this is equal to plt dot subplot. Then I will have 2 rows, 1 column, and then fig size equals to, let's do 12 by 10. Then SNS, I don't know. Okay. Then SNS dot box plot. In here, my data will be the X, and my axis will be the first index. Okay, then I can subplot, I can put a title. I'll say set title. I will call that feature of the, no, outlier of the feature. Let me just say feature outlier. Okay, then I can do the same thing for the target. Then I'll do plt.show. In here, I will just change my data from X to Y, and the axis that this will be plotted, it will be 1, and then I can change this to target. So this will plot. Okay, now so looking at this, we would see that the cement does not have an outlier. Blast furnace has an outlier at the top. This doesn't have. This water has at the top and bottom. This has. So what exactly is an outlier? Well, an outlier is just a data point that has a value that is quite different from the majority of the rest of the data point. You understand? Let me give an example. So say for example you have an examination in a class and majority of the students scores something between 50 and 70. If there is a student who scores 95, that student is an outlier. That data point is an outlier because it's just one student that scores it. You're not going to pick that and say, oh, the majority of the class passes. You're not going to judge the result of the class by that one student that scores 95. Also, if there is a student who scores 10, you are not going to say, oh, the students failed because one person failed. So the one that scores a very incredibly high score and one that scores a very incredibly low score, they are outliers. They don't fit in what the majority has. So if you plot the Gaussian curve, the normal distribution curve, you would see that the majority of the data points will fall in somewhere around the mean, not at the tail, or at the tail of the right and and left. Okay, so that is what an outlier is. This is more or less like an histogram. Okay, I mean more or less like a normal distribution curve, or maybe skew to the right, skew to the left. The method that we need to segregate the outlier from the rest of the data point, there are different methods. I will do the IQR method and the z-score method. So let's see what the IQR method is. Let's try to explain with the data that we have in here and keep it short and fast. So this is how a typical box plot looks like. You have the whisker, so, and then you have all right. So what this is, basically, this is your Q1, which is your 25th percentile. This is your Q3, which is your 75th percentile. And here, what you have is just the median, all right, which is the 50th percentile. This is like the maximum value and the minimum value. So the first step we're going to do is that we are going to calculate the IQR. So IQR is called interquartile range. What is IQR? IQR is simply Q3 minus Q1. But then when we want to use this, we usually multiply a value of 1.5. You can change that, you can manipulate that number, but 1.5 is more or less like the standard. So we multiply a value, let's say 1.5 multiplied by the IQR, and then that value we use it to like go forward and then go backward. In order for this to make sense, let's look at the actual value that we have. So let's pick a data point in here. Let's look at water, because water has outlier at the top and outlier at the bottom. So what is the Q1 for water? The Q1 for water, which is 25 percentile, the Q1 for water is 164.9. So Q1 here is 164.9, and the Q3 for the water, the Q3 is 192, right? Is 192. So when you do your IQR, Q3 minus Q1. So if I do 192 minus 164.9, I have 27.1. So it means my IQR, this one, is 27.1. And then if I multiply this by 1.5, I will have 1.5. I will have 40.65. Now, you would see that what we are trying to do now is that, okay, if you have 164.9, we want to go backward by 40.65. So if you say Q1 minus 40.65, so you will have maybe, let's say, something around here. You know, Q1 is greater than this value. Q1 is greater than 1.5 IQR. Okay, so we are basically just adding backward. So we say Q1 minus 1.5 IQR. So you can arrive at this point. Also, at this point, we can add this value of 1.5 IQR. So we would say Q1 minus 1.5. Oh, that's 164.9, right? Minus 40.65. So this point is simply 124.25. And then if we do Q3 plus, which is Q3 plus 1.5 IQR, okay, we will have something around here. Yeah, so that will be, what's Q3? 192 plus 40.65. So we have a value of 232.5 0.65. Now, basically, what we're trying to do is that any value of water that is not between 124.25 and 232.65 is an outlier. That is, any value that falls in this part is an outlier, and any value that falls in this part is an outlier. So for a value not to be an outlier, it needs to be between 124.25 and 232.65, which is between this part and this part. So in simple term, that is what IQR method is. So in here that we use 1.5, you will realize that this point that we use as a boundary, as a threshold, is being judged by this 1.5. So if you want to increase or you want to reduce this boundary, you can play with this 1.5. You can say, maybe for yourself, you want to use 2.0, or maybe you want to use 1.0. It's left to you, depending on how much you want to catch the outliers. Okay, so this is where you decide on how much you want to catch your outlier. All right, so let's code this simple mathematics. So I'll be first with that. All right, so the first thing I will calculate is the Q1. Q1 equals to x dot quantile 0.25, which is the 25 quantile, and then Q2 equals to x dot quantile 0.75. Then the next one will be the IQR, which is simply Q3 minus Q1. I have to change this. I don't know why I used Q2. Q3 minus Q1. And then I will look for my lower outlier. Now, the logic we are going to do here is that, well, we said this is the lower outlier, right? And this part is considered the upper outlier. So for simplicity, lower outlier means that, okay, so here is the lower outlier, right? So lower outlier simply means that any x that is less than Q1, this is Q1, that is less than Q1 minus 1.5 IQR is a lower outlier. Is this point. Any value that is less than Q1 minus this value, okay? Because from here to here is just 40.65, right? 40.65. And then the upper outlier here, don't forget that from here to here is 40.65. So Q3 plus, exactly. So that'll be x greater than Q3 plus 1.5 IQR. Good. And then the values that are not outliers, the value that are clean, will simply be a value. That is not Control Z. It will be value that is not, lower outlier or upper outlier, right? So that is exactly what we're going to code up now. I will come back here and then I'll say lower outlier equals to x less than Q1 minus 1.5 multiplied by IQR. Put this in the bracket, right? Then I'll do dot sum, because if I don't do that, that greater than is going to give me a boolean full true, false, true, false. So lower outlier. And how many do I have? Only water has a lower outlier. Let's confirm. Yeah, you see this doesn't have an outlier. This has an upper outlier. This doesn't have. This has upper and lower. Every other thing does not have a lower outlier except for water. So that looks good. Then I'm going to use this similar syntax for the upper outlier. That will be x greater than Q3 plus 1.5 IQR. So the total outlier will simply be lower outlier plus upper outlier, right? Good. So if you want to now check, I believe it's water that has the most outlier. So water has the most outlier, as you can see, 15. Then next is super plasticizer. So if you add 2 plus 15 plus 10 plus 5 plus H, H has the highest outlier actually. Then plus H, if you add everything up, if you do dot sum, you will have 91. So it means we have a total of 91 outliers. Initially, we have reduced our observations from 1030 to 1005. So now if we remove 91 from 1005, we have something like 900 and whatever. So now that we have identified 91 outliers, what we need to do is to remove those outliers. And how do we do that? Let me call my X. Now it will be X clean. My X clean will simply be the I will loop through what I have in there. So I'm going to use this syntax, as I said, that anything that is not lower or upper. Okay, if it is not lower or upper, so I will just simply pick this lower, right? Then or, that's the or sign, then upper, Ctrl C, then upper, then I'll put them together in a tuple. Then I need the not sign. Not sign is usually represented with let's say, okay, whatever. Let's say we want to use let's say approximate symbol. Yeah. Then I'll pick this sign, Ctrl C, and then I'll just place it at the front here, and then I'll say dot any, so axis equals to 1. Then I have my X clean. So if I try to see my X clean dot head, this is X underscore clean. Yeah. So if I try to check my X clean, you would see what I have, but there is a problem with the index, which is normal. It means we have removed 2, 3, 4. We have removed 6 as well, due to the fact of how we removed, all of that. So now that I need to calculate my Y clean, not calculate, now that I need to also broadcast mask my Y clean, I can simply just look for the index here. I can say X clean dot index. So these are the index of X clean. I'm going to use this index to mask my Y clean. So I can simply say my Y clean equals to Y, and then I will do this. Then I like to see before I move on. Y clean, then I have an error, none of index, blah blah blah. The type int length. Okay. Okay. So when we were separating our data, you remember we used 2 parentheses here, so we treated it like a series. So we have 2 options to fix this error. Either we remove what's it called? Either we remove this inner bracket so that we have only 1 bracket, or maybe we use dot lock instead of using Y here. I'll just use Y dot lock. Yeah, so then I'll run this, and then this is fine. Then the next thing I will do will be to concatenate the X clean and Y clean so that we can have the data to look the way it was looking before, like the way it was looking like this, that we have the feature and targets together. So I will concatenate them in the axis 1. So I will say clean data. I will say clean data equals to pd dot concat, and then I'll put this in a list. I will have X clean, Y clean, then axis equals to 1, and then I will see again X clean dot head. Now if you check this, you would see that the index is not correct, as I said earlier. So what we just need to do is to reset the index. So X clean equals to X clean dot reset underscore index. Okay, then drop equals to true. I will cut this, place it here, and then we run this. So now we have a clean data set. So our new data set now is no more clean data. Control C. What I wanted to see was this. Yeah. So oh no. X clean. Control C. Control V. Control V. Yeah. Okay, so this is what I wanted to do. 0, 1, 2, 3, 4. So nice. Then this is our new data. Our new data is just clean data, so we can feed this into our data. If we do clean data dot shape, you would see that the number is now 919. So from 1030, we have come into 919. It is better for you to train your model, any machine learning model, with this 919 data points than using the original 1030. So your model will be better with this. So another method will be to check the z-score. So we will not spend much time on the z-score like we did with the IQR. So z-score is okay, maybe we'll do that in the next video.